Okay, greetings dear friends, welcome back to my channel. So today we're still going to look at PIC microcontrollers, and immediately after this video will be about right now Arduino. So just make sure you subscribe to keep track to everything about programming of microcontrollers in my channel. So let's get started by opening our software required. First we need our MP lab. Apart from MP lab, we also need our Proteus. So let me start them before we begin the work. Okay, that will be okay for now. So let's get to our MP lab. I showed you guys already how to start a new project, so I'll be a little bit fast for those who have been there, and for those who are just coming, please make sure you subscribe so that you get the recent videos and the present one too. So I'm just going to remake back the steps but very fast. Okay, here right now you're going to browse to the folder you want and make sure you know the folder where you're keeping it. Mine is Athlete Projects in my desktop, so keep it in the folder you want. So I'm going to save my own project as Let Blink. Okay, so what exactly are we going to be doing here? That is a question. So what we are going to be doing here right now, last time we saw how to blink a LED using PIC microcontrollers. That's with delay. So this time around we are going to learn subroutines. We are going to look again at labels and at delays. Same thing also, we are also going to look at different keywords again in the PIC microcontrollers. That's how to input a value to the PIC microcontroller. So what we are going to be doing specifically is controlling the blinking of the LED with the help of a switch. So let's start by naming our CPU being used. That's 16F84A. From there we talk about the library where the assembler will be getting it from. That's a P16F84A. Okay, the A needs to be in caps and the P needs to be in caps. Those are slight errors you usually do during programming. So apart from that, right now we initialize our terms. That's what the status him is equal, our status register is equals 03H. Make sure you look at the diagram I showed in my last videos. Like I said, subscribe so that you see the previous videos. And port A right now, him is equal 05H on the back, and we have right now trace A, him is equal 85H on the bank 1. So right now we're going to initialize count to perform our delays. So let's talk about count 1. Him is equal a general register, that's 08H. And right now we talk about count 2. Him 2 is equal a general register. Is equal a general register, that is 09H. So everything has been initialized. You know to make the microcontroller know which port will be input and which port will be output. That is kept in our bank 1. So we need to move from bank 1 to bank 0. So that's BSF, the status, comma 5. So we're already right now in bank 1. So we need to define which pins are going to be input and which pins are going to be output. So for our case here, we're going to take as input the first pin on our microcontroller. That the first pin on our microcontroller will be the input and the rest will be output. So for that to occur, we are going to say 01H, where the 1 there stands for the input. That's okay. We move this right now from the working register to the file register. Which file register right now? That's in bank 1, right? That's trace A. Okay, so we'll come right now back to our bank 0 to perform our various operations. That is comma 5. So everything here is okay right now. Let's start our operations in the PIC microcontroller. So to get started, we'll start first of all by creating our label that will permit us to do looping. So after the label, we on our LED. That's to on the LED, we need to send an output value to the second pin. That's why I'm going to say 02H. So we are moving this value right now from the working register to the file register, and our file register we're talking of here is our port A. So everything being set, that is it. So our LED right now is on. We want it to be blinking, and want a switch to be controlling the rate at which will be blinking. So that is when the switch is off, will be blinking slowly, and when it is on, you blink faster, or vice versa, depending on you. Okay, let me put this on battery saver. Okay, from there right now let's proceed. So we are going to use a new keyword, that's a BTFSC, meaning that what bit test on the file register, skip if it is clear, that is it is skipping an instruction if it is clear. Why are we doing this test? We are doing it at port A specifically, I will say comma 0. So what's up about this? So if it's that I feel that it is clear, right? If that has tested a pin and it is clear, it's going to call a delay. A delay here is a subroutine, and it's going to call another delay, that's a subroutine, right? So that's the way it is. But if it checks right and it is not clear, it is a 1, it's going to perform only one of these subroutine, and it keeps the other one. That's the meaning of the skip if it is clear. So from there let's proceed. Like I said already, this delay is a subroutine in which we are going to create it. Okay, so let's proceed. A little bit of sign up. Yeah, so I said already that this delay is a subroutine. That's what we're calling it. We're going to define a delay at the end. So right now our LED was on. After that it blinks. So let's turn it back off. We know how to turn off, obviously. That's a move LW 00H, right? Yeah, we'll set everything to 0. I move this right now from working register to the file register of port A. Everything being done, that is it. So we're still going to perform the same action when the LED is off. You see, right? Okay, the same action occur when the LED is off. I think our code right now is okay. Hope you're understanding. If you don't understand, please drop a message at the comment section, or if you have anything to add to the code or to explain again furthermore in the code, drop at the comment section. So after this right now, we're going to say go to start. That's it, retakes back our loop. In this right now, we're going to create a subroutine in which we name already delay, right? So since we named it already delay, we're going to perform looping here. So the looping right now will be decrementing f keep is 0, and the file register here is count 1. Yeah, we're decrementing it by 1. We saw already this in the previous site, and we say go to loop. Hope it's okay. So we're just going to copy this. Oh no, no. So we say decrement f keep is 0 of count 2, 1. And we say go to loop. Guess that's okay, and that's the end of our code. Everything has been rephrased, and hope you guess what the code is to do. Yeah, so we'll be controlling the blinking of your LED using a switch. So let's save our code and build it together so that we'll be able to check the error all together. So I'm just going to say LED control. So I save it, immediately the color changes, and let's build our code. Okay, right now they're telling us that build failed, reason being that we didn't add our source file. So let's add our source file. How did we save it again? We said LED control, here it is, right? Yeah, so we have added before we built. So they'll actually say absolute. Okay, right now they're telling us that the build failed. Yeah, you can see the error. They say error 105. Let's check the error together. This is what I wanted. Okay, they're saying include file this not found. So the error is just that we didn't place our .inc. So if you're able to, you should be able to troubleshoot your code. So let's build it right now together. They say build was successful. So let's go right now to our Proteus to build our circuit very fast. we need a 16F84A. I will need a switch. I will need a LED. I'm going to take a yellow LED this time. Okay. Okay, let's place our PIC. Our LED, according to our LED, the LED was connected to the second pin of our microcontroller. So here it is. We connect it there. Switch right now, here was connected to the first pin. Hope you saw that in the code. Else, if you have questions, drop at our comment section. We're going to respond in the next videos to come. So connect the cathode of our LED to the ground, and after that, right now we need to supply our switch so that when it is on, it gives a value to the PIC, a value high. So we're just going to supply it. So once you have placed this supply, you are going to change it to 5 because it's 0. This is 5, and then you say enter. Everything right now is good to go. That's the code. Let's upload our code into our PIC microcontroller. Okay. Mine was a desktop. I told you to make sure you retain where you are saving your project, and it was let project. You are taken by the .hex, not the .conf. So we load it. But right now we're going to change the frequency so that at least we're going to be seeing how it's changing. You can still leave it at 1 megahertz depending on you. Okay, everything. So let's see the behavior of our code. Okay, something right now is happening. The LED is just shining. Okay, meaning it does not obey our delay. Let's get back to our programming and troubleshoot it again. Okay, so the idea right now here was that, so right now, like I was saying, we need to troubleshoot our code. So I don't know if you guys did it very well, but the error actually, we created a subroutine here, and our subroutine normally, after creating a subroutine, for the assembler to recognize that it was a subroutine, we need to say return. So once you have called your subroutine here, we called him. After it has performed what it had to perform, it has to return back to and continue the main code. So let's save it. Let's save it and build it back. Okay, build successful. Let's upload it. Let's upload it into our PIC controller. We're going to take the new one. That is a LED control.hex. Okay, everything been equal. So run right now. Okay, so hope right now you can see the behavior of our LED. If right now I on my switch, you can see the rate at which it is blinking, right? So take note of that. If I on my switch, the rate at which it is blinking has slowed down. That's slowed down. So that's what our code was expected to do. Like I was saying, most of these errors I do them real fully so that at least you see them whilst you are doing your own project too. So always make sure that after creating a subroutine, you say return after that. So that's what I left out. And when creating a header file, always put .inc. Okay, that's one of the small errors too. And before you build your code, always add it to the source file. So thanks you guys for watching. You guys can comment your question in the comment section. Hope you guys subscribe to the channel to keep track of the different videos we continue having. So like you guys know already, we're not only dealing with PIC microcontrollers here, but also deal with the AVR family microcontrollers as the Arduino microcontrollers. So keep track, subscribe to the channel. Thanks you guys very much. Hope you guys see this again.